Hi guys, it's Cian here with STEM for Others, and welcome to Unit 1, Lesson 3 of Intro to Robotics. And today we're going to be talking about coding for your robot. Okay, so Scratch is a block-based programming language, and it's just like Spike Prime, so you can use it to make games, animations, and tell stories. It uses similar commands to Spike Prime, so it is a great way to get used to the block-based programming that Spike Prime uses. So regarding steps, you go to Scratch and you go to scratch.mit.edu, and that's the website. You follow the tutorial in the small box towards the bottom of your screen. And you can explore, you can do different tutorials after you finish the first one, and you can just go ahead and code. You can keep exploring more tutorials, and once you get the hang of it, you can try making an animation or a little story all by yourself. Spike Prime. So Spike Prime is LEGO Robot's coding platform, and just like Scratch, it uses block-based coding. It lets you control motors, sensors, and your robot's hub. So as you can see, regarding the attachments as well in the prior video, everything in the robot really flows together, so make sure everything is consistent throughout your robot. So here are some block categories. These blocks control multiple motors together to move the robot forward, backward, or turn. So make sure that your axles and the wheels are properly flowing together. So just remember that. Motors. These blocks control motors. You can turn them on or off, set power or speed, and control direction or rotation by degrees or rotations. So make sure your motors are in the right places and, that they're just attached properly to the robot. The sensors are these blocks that read data from sensors, like touch, color, or distance. And in the prior video, I also used a machine learning sample of a robot. And if you have if you want something in front of the robot to be steered away from, then you would use a sight sensor in front of it, and it would turn away if that's what was coded in the hub. Regarding control, the category includes loops, decisions, and timing. These are used to manage the flow of your program. Okay, and here's some more. So events start scripts when something happens, like when the program starts or a button is pressed. Light. These blocks control the LED lights on the hub. Sound. Sound blocks play sounds through the hub speaker. You can choose preset sounds, play tones, or record your own, which you can later attach. Variables. This category is for creating and using variables. It's pretty straightforward. Operators. These are math and logic blocks. Use them for calculations, comparisons, and combining sensor values or conditions. My blocks. This category lets you make your own blocks, which are basically the functions to group and reuse code. Coding in Spike Prime. Step 1. Click the Connect button on the top left. Step 2. Turn on your hub by pressing the highlighted button. Step 3. Turn on your Bluetooth by pressing the highlighted button. So the first highlighted button is right here with the green-blue circle, and the second one to connect to the Bluetooth is the one on the opposite of that, which is lighter blue. Step 3. Click the open button and find your hub. And don't worry if you can't use the instructions right here, because these instructions are in Spike Prime as well. Okay. Pseudocode is a version of your code that is written in words. It is a way to plan your coding using simple steps before worrying about syntax. So I would really recommend using pseudocode if you just have a very complex code and you just need an outline for it. I totally recommend starting off with this, because you just get an idea and you can make quick edits to it before you really start coding, and that's when it becomes more complex to make changes. Turning/steering angle. In Spike Prime, steering angle controls how much the robot turns while driving. The steering angle tells your movement motors how much to turn together. Different steering angles are used for different turns. So if you need the robot to go in a straight line, then your steering angle would be 0, since you're not moving in any direction. If you want to have a pivot turn, you do like the 50, and if you need a wide turn, you do like 100. And that's also plus or minus, depending on what side you're going to. The gyro sensor. The gyro sensor is an internal sensor in the spike prime hub that detects rotational movement. It measures the robot's angle and rotational rate. This is important for our code because using the gyro sensor ensures that the robot can turn at a precise angle. So if you want to use it, reset the angle at the start of your code. So set the gyro angle to 0. Read the gyro angle, and that will give you like the angle. Pitch, roll, and yaw. There are 3 different directions that the gyro sensor senses, which is again pitch, roll, and yaw. Pitch is when it tilts forward and backward. Roll is tilting side to side, and yaw is rotating left and right. So now it's your turn. So the steps for coding in the hub, like we said before, were to receive your hub, download the app, and follow the instructions and code. For coding the motor, again, it's the same thing, but there are just different sections in it that you can use. But for coding the whole robot, which is a bit different, after you download Spike Prime, in Units, click on Competition Ready, then click on Training Tramp 1 Driving Round, and then you can start coding as well. And if we're going to talk about the programming project, which is a square. So the objective of this one is to program your robot to drive in a perfect square, making 4 90-degree turns that use the steering gyro sensor. So as you can see, you can kind of like infer that everything is just working together to highlight a goal. Write the pseudocode and then the final code. It makes it so much easier. Use control, sensor movement, and operator blocks. So just incorporate what you can. Materials you're going to need is the Lego Spike Prime Hub, which is like the rectangular piece that we saw. You're going to need 2 large motors. You're going to need a drive base, which is a 2-wheeled robot, and a flat surface. So extensions would be lights or sound at every corner. Make it in an equilateral polygon. You can do that using the variables and use my blocks. So just try to be as creative as you can. Try to do a lot. And another programming project is the maze. So the objective is to create a tape maze and then program the robot to navigate around the course. Write pseudocode and final code and use the control sensor, movement, and operator blocks. The materials you're going to need are again the Spike Prime Hub, 2 large motors, a 2-wheeled robot as a drive base, and a flat surface. The extension would be to add a timer to track how long the robot takes. Try using a color sensor instead of manual input. So there's just so much you can do with it. So just try your best and, explore your creativity. Okay, that is it for this video. Thank you for joining me, and I will see you in the next one. Thank you.